PQRS is a trapezium with PQ parallel to SR and SPQ is equal to 90 degrees. SQ equals to 15 centimeter, QR equals to 11 centimeter, and PSQ is equals to 58 degrees. This all is mentioned in the diagram. Calculate PS. First of all, let's figure out how to calculate PS. This is PS that we are trying to find out. This is a side of this right angle triangle. Okay, angle is triangle PSQ. Okay. PS is the side of a right angle triangle SPQ. So I'll only consider the right angle triangle and I'll try to find out the length of a side. If I have a right angle triangle and if I have the length of the other two sides, I can find out the length of the missing side. Or maybe if I have one side and an angle, I can use a trigonometric ratio. I have an angle and I have 15. 15 is the hypotenuse of this right angle triangle. I have this angle. According to this angle, PS becomes adjacent. So I have to calculate adjacent when hypotenuse and angle is given to me. Which trigonometric function should I be using? I should be using cos, which says cos theta equals to adjacent upon hypotenuse. So I'll write cos, angle is 58. Cos 58 is equals to adjacent upon hypotenuse. Adjacent is PS upon hypotenuse is 15. So I'll move this 15 over there and multiply with whatever is the value of cos 58. Cos 58 is 0.529. This is 0.529 multiplied by 15 is equal to PS. When I multiply 0.529 with 15, the value which I am getting is 7.95. So PS is going to be 7.95 centimeter, or maybe you can round it off up to 8. This is PS, not P. So I'll mention PS. Okay, then I have part 2. Calculate the obtuse angle SRQ. This is the angle which I have to find. If I was making this video for maybe an appearing year student or maybe a grade 10th student, I would have told them to use the sine rule. But since I'm making this video for a 9th grader, I am going to use a different technique to find out the angle SRQ. What I'm going to do, I am going to join R with that side. Okay, what I have done, I have dropped a perpendicular from R on PQ. I have dropped a perpendicular from R to PQ and I've got a right angle triangle. This is a right angle triangle that I now have. Okay, now what I have done, the angle which I had to find out, I have divided that angle into two parts. This is one part of that angle and this is the other part of that angle. This other half is 90. If I know that blue part of this angle, I'll be able to calculate the whole angle. So this is the part which is missing. This is the part which I do not have. Since I have converted this into a right angle triangle, PQRS, let's say this is T. So I have a triangle RTQ and I am going to do something with triangle RTQ to find out that angle. I know the length of PS. PS is, let's say, 8 centimeter, as I mentioned while solving question number 1, that I can round it up to 8. If PS is 8, then this side is also 8 centimeter. Now, if I look at right angle triangle PTQ, I can use trigonometric ratio to find out that angle TRQ. Which trigonometric ratio should I be using? The angle which I am trying to find out is at R. With this as my angle under consideration, TR becomes adjacent and 11 remains the hypotenuse. So what I am doing, I am using cos. The angle that I am trying to find out is angle TRQ is equals to adjacent upon hypotenuse. Adjacent is 8 and hypotenuse is 11. In order to get to the value of angle TRQ, I'll take cos inverse of 8 upon 11 and 8 upon 11 becomes 0.727. So I'll take cos inverse of 0.727. Cos inverse of 0.727 is 43.34. So this angle is going to be 43.34 degree. This is just that blue part of that entire angle which I had to find out. Means I have this value which is 43.34. Now that I have this angle, I can add it with 90 and then I can have this entire angle SRQ which I needed to find out. So for angle SRQ, what I am doing, I am adding 43.34 with 90 and the answer is going to be 133.34 degree. Do remember that I have used this approach for a ninth grader to solve this angle. If an appearing year student or a 10th grader at least is trying to solve this question, they may use a different approach to solve this question. They may not use this way, yeah, this method of solving for the value of SRQ. They'll be using the sine rule. They'll not be using this approach. Okay.